Hey, welcome back to POE. Today we're going to be talking about outputs and how we start the kind of the thinking process with these outputs, and we do that by creating flowcharts. Okay, definition of a flowchart. A flowchart is a schematic representation of a logarithm or a process. And we kind of put together step by step, and we put these in. We're going to find out that each of these shapes represents something entirely different. But a logarithm is like a program. This is kind of how your computer thinks. So by working on these flowcharts, you're going to better understand how your computer thinks. And if you can understand how it thinks, you're going to be able to better and more quickly be able to program it. Okay, parts of a flowchart. Whenever we have these kind of ellipse, it's not really an ellipse, but a kind of a flattened ellipse, we can say, that's our start or end. And whenever we have these rectangles, it represents a process. Whenever we have a parallelogram, it's an input or an output. Right here's one, a decision. Whenever we have this rhombus, it means a decision has to be made. An arrow then typically is going to take us from one to another. And then a display is something that it doesn't really, we'll get into a display here in a short bit. Okay, start end. Shape is a rounded rectangle. I call it an ellipse, but start is required for all flowcharts, but not all flowcharts have an end. Okay, our rectangle here, it stands for a process. Shape is going to be rectangular. Here's the important thing, is it's going to involve an action verb. All right, this is the verb part of the flowchart. Examples include add one, turn the motor on, turn the light off, rotate the part, turn the motor off, and I'm just coming up with a few others. Wait. These are right here are all part of the process. Input, output. This right here is it's a parallelogram. Indicates that manual operation is needed. So the parallelogram is whenever you're going to have to do something or the operator is going to have to do something. Type in the weight, check the balance, time the operation, hit the bump switch, hit the limit switch. You're going to have to give it some input. Turn the potentiometer to certain dial reading. These are all our inputs. Okay, the rhombus. This means there's going to be some type of decision. The outcome is either a yes or a no, because computers only know yes or no. You ever heard of binary code? That means yes or no, and basically it just means turn this on, turn this off. Examples include, is the number larger than 10? It's yes or no. Does the weight meet specifications? Yes or no. Has the count been reached? Yes or no. A computer is going to only understands yes or no questions. Okay, arrows. Arrows indicate the flow of the chart. Arrows are drawn from the output of one block to the input of another. Only one arrow can represent outputs, but multiple arrows can represent inputs. Okay, here's going to be an example for us. Count from 1 to 9 by odd numbers. Before attempting to draw the flowchart, determine what you want the output to be. What is the first block? Well, it's always going to be the start. All right? Your output will be 1, 3, 5, 7, 9. Your start block is always first, so we'd always start with start. The program begins with the number 1. So right here, if you remember, what does our parallelogram mean? Our parallelogram meant an input. You're going to have to put some information into the computer. Okay, the next step, now that there's a number, the program will state the number. Right? This right here, again, was just a process. This is going to be the verb. All right? The rectangular is the verb for us. Now we're going to have another process here. We're going to tell it, right? Add 2 to it. We want to get to the next odd number. We do that by adding 2. Now that we've added 2, we've got this new number, and the computer is going to have to make a decision. Right? The computer is going to have to make a decision. Is the number greater than 9? Well, no, it's not. So you see here, what that tells the computer then is to go back through this same process again. We're going to say the number. Right? We had 3. Add 2 to it. We get 5. Is 5 greater than 9? No. We keep repeating this process. Say the number. 5 plus 2 is 7. Is 7 greater than 9? No, we repeat the process again. 7 plus 2 is 9. Is 9 greater than 9? No, we repeat the process. Finally, we've repeated this process. 9 plus 2 is 11. Is 11 greater than 9? Yes, so we end the program. This is very similar to how a computer operates. It's just simply one step at a time. Here's a chance for you guys to earn some bonus points. Create a flow chart that shows how to pour a glass of milk. I'm going to give you 15 bonus points for this. For those of you that come in and actually listen to this, you're going to get 15 bonus points. For those people who didn't listen to it and come in and turn it in to me, I'm only going to give them 10. So we'll find a way to get that established up there at the top. Probably the people who didn't listen to this, they're going to ask me how much it's worth. Hey, I'll catch you guys on the flip side.